So let's go do a quick example here. Example 2, again, we highlighted that in blue. Examples are in blue, and then again, we'll learn something about complementary, which we'll highlight in green. So example 2, in this figure below, or to the right kind of, we know that the measure of angle 4 is in fact 98 degrees. So I'm going to just highlight that in green here. So let's just say, hey, this is angle 4. Again, I would like you to highlight these as well. This angle right here, let's go ahead and write it down. This is 98 degrees. So I actually physically put it in there. That is something nice to know. So we can actually find angle 1, angle 2, and angle 3 very quickly here. So I'm going to actually find the measure of angle 2 very fast. And the reason why is because if we remember, these angles 4 and 2, are going to be vertical of each other. So this is in fact the same as that. That's also 98 degrees. That is 98 degrees because it is vertical. Vertical to angle 4. And that would be a way you should write it down. So like if you were taking a test or a quiz or whatever, you'd be like, well, it's 98 degrees, but why? Why is that true? Well, I would have to say it's vertical to angle 4. That is something I need you to write down. It is very important to justify your thoughts and reasoning in geometry or any math in general or life. So that is our key step there for angle 2. Very easy to find. But let's find this angle. Let's find angle 1. If I can find angle 1, that's not that hard to find angle 3 then, because we know that angle 1 and angle 3 are in fact vertical and they are the same. So I just have to find angle 1 or I have to find angle 3. So if I think about it, we talked about linear pairs. So this right here and here form a linear pair. That is a straight line. So angles 1 and 4, this makes a line. 1 and 4 are going to create a straight line. So if I write that down, let's do this in orange. I want to just say the measure of angle 1 plus that measure of angle 4 is in fact a linear pair, which we're going to just say linear pairs as a reason. And I'm going to put those in kind of those parentheses. So let's just put those there as well, just as like justifications on the side. So what we do know is that measure of angle 4, we talked about this, is already 98 degrees. So we just substitute this in to there. So we still have the measure of angle 1 plus 98 degrees now is equal to 108 degrees, which is again substitute. So make sure we put substitute. And then all we have to do is just subtract that to the other side to find the measure of angle 1. So the measure of angle 1 is in fact equal to subtracting this 98 because it's adding, the opposite of adding, we subtract 98 to both sides, gives us measure of angle 1, which is equal to 82 degrees. So we have the measure of angle 1, we have the measure of angle 2, and we can put as a justification here, so just subtract 98 degrees to both sides as a kind of a justification. And then the last one is angle 3. Well, 1 and 3 are the same because they're vertical. So we can just say measure of angle 3. So let's do that in blue. So measure of angle 3 is equal to that 82 degrees. And again, that would be because they're vertical. Vertical to angle 1. That would be my justification there, and I'll put those in the brackets. Okay, so that is kind of how you do it. Sorry, it's a little crowded in there. Maybe you have better handwriting and can write smaller than me. So let's go ahead and move on to the next thing, which is complementary angles, which very similar to supplementary, but they're just two angles or a pair of angles that measure or add up to up to 90 degrees in this time. So let's highlight that. They're a pair of angles whose measures add up to 90 degrees. So if I draw a picture, we have something like this. we can make a right angle. So if I just make a right angle here, which we know is in fact 90 degrees, I can draw a line somewhere in there, and these two angles right here, this, let's do this in orange, so that this angle 1 and this angle 2 would be complementary. So measure of angle 1 plus the measure of angle 2 is in fact equal to 90 degrees. That is one way we can do it. Another way is if we just have two separate angles. They do not have to be adjacent. So I could be something like this, and we could have something way over here. Again, something like this, but a little bit bigger. No, that's a little bit too big. Let's go ahead and make it more like that. And let's say that's 60 degrees and this is 30 degrees. But 30 and 60 is in fact 90 degrees. So angle A and angle B here would be in fact complementary of each other. Okay, so just thinking about supplementary and complement, what is the complement and supplement? Those are the idea of these. An angle measure is in fact 49 degrees. What is its complement? So complement means 90. So the idea is 49 plus what is equal to, so 49 plus what is equal to 90, because complement equals 90. And then for supplement, it's like, well, 152 plus what is equal to 180. And that's degrees, obviously, so make sure you have the degree symbols. And you're just finding those question marks for both of these. So, which very nicely, this one, you just do 90 and subtract that 49, which is in fact 41 degrees. Let's rewrite the 1 here, 41 degrees. So we'd have 41 degrees, and then 180, we just subtract that 152 to that side to find that question mark. So this question mark is in fact equal to 38 degrees. Again, double check 38 plus this is actually wrong because that's 190. It's actually 28. Oops, sorry, my bad. So this should be 28. That's why we always double check our answer. Maybe that was important that I wrote that down. So make sure you double check. And then double check here as well. So 41 and 49 is 40 plus 40 was 80. 9 plus 90 is so perfect. So let's go ahead and do our last things, which are doing supplements, complements, linear pairs, vertical angles. Maybe I'll rewrite this actually. Here, let me erase this and write it a little bit better so it's easier to see. 28 degrees, just to make sure. Again, 20 plus 50 is 70, plus that gives us one more, another 10, which is 80, so 180. So let's think about our last ones. And we're going to use linear pairs, complementary, supplementary, and vertical angles. So how do I do this? So we know that the measure of angle 1, let's do this in red, measure of angle 1 is 3x. So this right here is 3x degrees. We know that the measure of angle 2, let me highlight this right here, angle 2 right here is actually equal to x plus 84, and that's all in degrees. We're going to have to find measure of angle 1 and measure of angle 2. The key idea is we know that this is a line which is 180 degrees. Lines are 180. Half of a circle, which circles are 360. So we are going to move this over just a little bit so I can write a little bit better. So the idea is we're going to take that 3x degrees. We're going to add this to this x plus 84 degrees, and that is equal to this 180 degrees. If we put angle 1 and angle 2 together, they're 180 degrees. Now, I like writing this first, personally, is the measure of angle 1 plus the measure of angle 2 is in fact 180. And then I substituted in both of those. So this is this linear pair. So like if I think about this, this is a linear pair for a justification. And then the next step is just substitute angle 1 as 3x and substitute angle 2, which is x plus 84. And now we just have to solve it. So one key thing is noting that you have a vertical line here. You can't cross it unless you do something to both sides. So in this case, that is very important because over here, a lot of people will take 3x and x and they will subtract 3x to over here, but no, we're actually combining like terms. So justification, we put terms together. So let's combine this and this, which is just 4x's. By the way, these parentheses just drop. There's all addition, so it doesn't matter. If it was timesing, it would change. But in this case, addition just drops those parentheses. And then we have this plus 84 degrees, and that'd still be degrees here. And this is still equal to 180 degrees. Sorry, it's getting a little bit crowded there. Now, what I'm going to do is I'm going to subtract this 84 to both sides because I don't want it on the left side. I want just the x's. So then you just have this 4x degrees is in fact equal to, let's keep this vertical line going. What is that? 96 degrees. Now we have to do the last thing of just dividing by that 4 to both sides, and we get that x degrees is in fact equal to 24 degrees. So this is super big, but we have to find what it's looking for. It actually asks to find the measure of angle 1 and measure of angle 2. So we have to take this and substitute it back into this x and this x here. So the idea is that measure of angle 1, that was in red, so measure of angle 1 is equal to 3 times that 24. And that would give us the measure of angle 1 is equal to 72 degrees. Now the measure of angle 2 is equal to x plus 84 degrees. So we're plugging in that 24 degrees for this one, and then we should get that the measure of angle 2 is in fact equal to 108 degrees. So these ones are a little bit more work, but it's very doable. So let's go ahead and have you check this one, but just notice that they are complementary, not supplementary. Pause it, and I'll have an answer shortly. So hopefully you tried it. Remember, angle 1 and angle 2 together are 90. You do some work by substituting. You solve for x, you get 14 degrees. You substitute those back into both of the original equations, so 2 times 14 and x, or 14 plus 48, which will give us 62 and 28, which in fact add up to 90 degrees. So hopefully you had that. Let's get into our last problem then, which is using vertical angles here. So the idea is we have two vertical angles. This angle here is going to be vertical to this angle here. So these are equal to each other. So the whole idea is we're going to just say that 6x minus 17 all in degrees is in fact equal to that 9x minus 74 degrees, because these are in fact vertical of each other. So if they're vertical, we know they're equal. Then we can just have this equation where you put that vertical line and we can move things to both sides. So I like starting by consolidating my x's. So I subtract 6x to both sides. By the way, these parentheses basically just drop, so we don't need them anymore. So on the left side, we're just left with this negative 17 degrees. And 9x minus 6x is in fact 3x in degrees. And then minus 74 is still there. Again, this degree would kind of distribute to both, so you kind of keep the degree with all of those. So then we're going to go ahead and now move the number to the other side. So let's add 74 to both sides. So this is in fact 57 degrees is equal to 3x degrees. Again, this is timesing 3 times x. There's no space, so we have to undo that by division of 3, and then we get x is 19 degrees. So that is the first thing we needed to find is x. But then the last thing, I want you to try yourself, but we need to substitute this in here, so we get 9 times 19 minus 74, which will give us, this is 97 degrees. So what would this be if that's 97? So pause it, I'll have an answer in a few seconds. You should have got 83 degrees.